So today we're going to do another question from 30-day LeetCoding challenge. So today is day 17, and the question for today is called minimum path sum. Given a m by n grid filled with non-negative number, find a path from top left to the bottom right which minimize the sum of all number along its path. You can only move either down or right at, at any point in time. Down or right. So we start. Find a path from top left to bottom right. So from here to here. So you can like go here. I think this is like a good question. So it's not necessary. It's like we do not always choose like the minimum value like locally. So like right here, from 1 we go to 3, then we go to 1 and 1, 1. I think for this question we can use like a star to do. So like for a star, there's like two things that we need to consider. One is like the distance from maybe we can use like priority queue. So first we look at this, and then we look at this 4 and 5 instead. So we explore 1, 3, and then 1, 3, and then we explore this is. So in order like to get to here, like in order to get to 5, you need 6, right? And in order to get here, you only need 4, so that's better. In order to like to move here, 5, and this is 6. Yeah, I really not sure how it's going to approach this. Let's look at the hints of the solution. So it's like the other way to look at this problem is how much does this cost, like to go from here to the goal? It would cost 1, right? Now it would cost 1 to go here, cost 1 to go here, and let me like try to write it down. So if we use dynamic programming, we will ask ourselves like how much does it cost to get to here. So there's only like two ways to get to there. One is like from top and one's from here. So both of them will require one to go to the goal. So finish, start. And how much does it cost like to go and how much does it cost like for 5 when you are here in order to get here? So it would cost so you have 5 right here and you have 4 right here, and to get to here, should we work like the other way? Let's see. Should we work like from start to finish instead? Right, so in order to get here we need 3, and in order to get here we need 1. That makes sense. And in order to get here we need, so we do like traverse like row by row. So in order to get here you would need, there's only one way to get there, so it would be 4. And down here there's only one way, like from top right here, so it would be so in order to get here it's like 4. In order like to get down here it's 2, and in order like to go here it's 5, and in order to get here, the minimum way like to get here, it's either like from here like right or go down. So this would be 2 plus 1, so 2 plus 1 is 3. So plus 5, so it would be 7. Let's get there. And from here to here would be 9, so we don't do that. And to get to here we need either like we are from here or from here. So it's like we want always like to find the minimum, like, so it would be 6 because like we want to go this way. And then for here we need to go down. There's only one way, so it would be 6. And here to here it would be 8. Here to here would be 7 because 6 is like the smaller one. Yeah, so the idea is basically we create another grid that represent like the value that it take to go like from the initial point to the target point. So what we can do is like we traverse through grid, and then we fill out the value, like the minimum way like to get to this point, the minimum way to get this point, the minimum way to get this point. And the minimum way to go to this point, it's basically just this one, because as the prompt said, we can only go down or go right, so there's no number on the right here, so there's only one possible way to go here. And in the case that we have 7 right here, so the cost to get here it's 5, but the previous cost to get down, like from 4, is from here is 4. So we calculate that oh, this is wrong. We calculate that we calculate that 2 plus 5 is less than 4 plus 5. That's why we choose 2 plus 5 right here. So like for every cell we have like 2 options or 1 option. So like for this case we have 2 options, like for number 6, because we either go from here or go from here. And the reason we chose 6 because 6 is smaller than 7 plus 1. So we keep filling like from left to right, row by row, so that we always have like a reference from left to right. Alright, so let's go ahead and do this. So let's search how to initialize n by m matrix in Python. Just want to see like what like the other way that we can do that. Yeah, normally I do this. So this will give us an m column and n row. Actually, array is equal to, we'll create a 2D array in which all n array will point to the same array. So any change in value and element will reflect in all n lists. A pattern that often came up in Python was which help motivate the induction of less comprehension, which convert that snippet to some expression which is shorter and some clearer. Usually you get in the habit of recognizing this and are often replacing loop with comprehension. Your code follow this pattern twice. For i's in range of 0, 10, u is equal to this. For j, that can be replaced with a list comprehension. I'm not sure if like each row is pointed to like the same array. If that's the case, that's not good. I think this is better. Yeah, I think this is wrong. As you can see, there are like 4 rows. Yeah, and here is definitely the column, and this is like the row. So just improvement. I think you mix up between row and column. I'm not a robot. Submit. So what we can do is we can call this a DP table, and this would be, so row would be the length of the grid, column would be the length of the first element of the grid. This would be the row, the column. And just like what we mentioned earlier, we want to start from top to bottoms. So we would go through for I in row, so we want to go through each row and then want to go to each column. And if I is equal to 0 and j is equal to 0, so if that's true, we want to assign the DP to be the same as the grid value. Otherwise, we want to update that value. So otherwise, we will consider top. So let's say like this case, we would consider like top and left. So top DP. So first we need to check if so top would be row -1 if I -1 is greater or equal to 0, or do top is equal to DP I -1, and then here's j. So otherwise top would be technically we want this to initialize to negative like infinity, because like for this problem we try to minimize the solution. And so, and if so in order like to go from left to right, go right, we need to do if j minus no that's j minus 1, yeah, j minus 1 is greater than or equal to 0. If that's true, no, not bottom, top, this is left. then we want to find, and then we want to update our dp I and j to be the minimum of else right here to be the minimum of top and left plus the actual value of that grid, which is grid I and j. And when we are right here, we can go either from here to or here. So I think it should be fine. And we want to return grid row -1 and column -1. So we go through the DP table to update the DP. So there's like two ways that we can go to that particular cell, either like from top or from left. So in order to go from top, we need to be like above that cell. So that cell above is I-1. And in order to go from left, that is like J-1. Looks good. Let's run it. Invalid syntax. Line 20. Oh, colon. Oh, this tea is so strong. In object is not iterable. Minimum path sum. Line 9. Oh, for I in range. String and in. One and 7. Let's debug the code. Yeah, we got 7. Why I return? Oh, grid. No, we want to return DP. Submit the code. Accepted. Ah, premium content. Right, that's about it. Let me go ahead and upload this.